Hello everyone, this is me Arijit with a new video, and in this video I'm going to talk about how you can serially communicate between Raspberry Pi and Arduino. Okay, so in this video what we are going to do is we are going to connect the Arduino and Raspberry Pi together, and then we will send data from Raspberry Pi to Arduino and from Arduino to Raspberry Pi through serial communication. Now as you can see here, I have Raspberry Pi 3B plus, Raspberry Pi 0 and Arduino Nano. But this process is same for all the Raspberry Pi and Arduinos, so like Arduino Mega or Arduino Uno and even a Raspberry Pi 4, it is same for all of them. Okay, now exactly what we are going to do is in this video is at first we will basically send data from Raspberry Pi to Arduino, then from Arduino to Raspberry Pi, and finally we will see how you can do a bidirectional connection, like bidirectional data flow, where we can send data from Raspberry Pi to Arduino read the data, and based on that, like, it will send some other data to Raspberry Pi, something like this. Okay, now coming to how we are going to connect this Arduino and Raspberry Pi. Now in most of the videos on YouTube, like, people have used this kind of data cables where you are just going to connect it with Raspberry Pi, and then you are going to just connect it with our Arduino Nano, and then now these things are connected and you can simply do serial communication. But here we are not going to do that. The first reason is if you are building a very small device, or maybe you want your final product to be very small, in that case you cannot use this kind of cables there. And the second reason is it's good for Raspberry Pi 3 3B plus, but if you think about using this in Raspberry Pi 0, you cannot. You have to use OTG and maybe other kind of converters. Okay, so what we are going to do is basically, as we know, in Raspberry Pi we have this GPIO pins. Okay, in Raspberry Pi 3 or 0 or any other Raspberry Pi we have GPIO pins, and in GPIO pins we have TX and RX in Raspberry Pi, and also in Arduino we have TX and RX. Now we can simply connect the TX of Arduino to RX of Raspberry Pi and RX of Arduino to TX of Raspberry Pi, and then we can do the serial data communication. Okay, but there is a small problem. As we know, Arduino like works in 5 volts, whereas in Raspberry Pi the data level is like in Raspberry Pi all the GPIO pins works in 3.3 volts. Okay, so whenever you are sending data from Raspberry Pi to Arduino, it is fine because you are sending a 3.3 volt signal to a device which supports 5 volt signal. But when you are sending a data from Arduino to Raspberry Pi, in that case you are basically sending a 5 volt signal to a device which only supports 3.3 volts. So in that case your Raspberry Pi may get damaged, so we cannot do that. For that we need one of these logic table shifter. They are very small and cheap. Now if you see, like, you can buy any of the logic table shifters. They are also called 5 volt to 3.3 volt shifters. So like in all of the shifters there are two sides. One is low volt side and it will be written as LV or 3.3 volt, and there is a high volt side which will be written as like HV or 5 volts. Now you connect the low volt side with Raspberry Pi and a high volt side with Arduino, and then we can do the data like you can just serially send or receive data. Now let's just talk about how you can do the connection. So let's just first talk about the Raspberry Pi. So at first in the low volt side you will connect a 3.3 volt pin with the 3.3 volt pin of Raspberry Pi, the ground pin with any of the ground pins with Raspberry Pi, and then the TX with TX of Raspberry Pi, RX with Raspberry Pi. Okay, now where is the TX and RX pin of Raspberry Pi? It is the physical pin number 8 is TX and 10 is RX, and in GPIO pin number GPIO 14 is TX and 15 is RX. You can also see the pin numbering in the diagram in the screen. Okay, now in this way you are going to connect to TX, RX to RX. Now coming to Arduino, we are not going to do that. Like in Arduino it will be not TX, RX. So obviously at first you are going to connect a 5 volt of the high volt side to the 5 volt of Arduino and ground to ground, and then you are going to connect the TX of this module to RX of Arduino and RX of this module to TX of Arduino. So reverse. So basically in Raspberry Pi we are doing TX, RX. In Arduino we are doing TX, RX, TX. This is the only difference. And after this our connection is done, and then what you need to do is, like, another thing you need to remember, that whenever you will upload the code in Raspberry Pi, you must remove the RX-TX pin. Okay, so so initially we are going to connect all these 4 pins with Raspberry Pi and Arduino, and after that when you will upload the code, you will just remove the RX-TX pin from the Arduino, you upload the code, then again you connect them up. Okay, and in this way every time you will upload the code you have to remove the RX-TX pin, else it will not work. So this is all about the connection, guys. Now let's just go to our computer and see how we can actually code this thing so that we can do a serial communication. Okay, so the first thing we need to do is we have to get into our Raspberry Pi. Now for that I'm going to use PuTTY. Now like SSH connection, but you can use BNC or direct HDMI connection, whatever you want. Now let me log into my Pi. Now I am now inside my Pi. Now the next thing is we have to open our Arduino IDE. Now I already have connected my Arduino with the computer. Okay, and then I am opening the Arduino IDE so that we can write some code. Now in Arduino it doesn't have any issue. We can simply write the code and like it will get uploaded and we can use it. But for Raspberry Pi to use the serial communication, we have to do few things. Now why? Because by default, like in Raspberry Pi, the Raspbian OS basically uses the serial communication for console login. Okay, so we need to disable that so that we can use the serial communication to send and receive data like to the Arduino and from Arduino. Okay, so for that we need to follow few steps. Okay, so the first thing we need to, so if you just go to my GitHub repository, the link will be in the description. You will get an instruction file where everything is written, like how you need to do that and all the commands. So at first you need to do this thing. So you have to just change the config file. So basically you have to edit the boot config file. So you just write sudo nano boot config.txt. Okay, and in the config file you go at the end of the file. Okay, you don't need to change anything here. You go at the end, and there you have to add this 4 lines, or sorry, this 5 lines. Okay, so as you can see I already have added them. So you just add them and then you press Ctrl X and then Y if you're using PuTTY, else you can use any text editor you want. Okay, so here we have like edited the config file. The next thing we need to do is we need to create a backup of the CMD line file, boot CMD line file. Why? Because we are going to edit the CMD line file. So if anything goes wrong, or maybe after some time like you want your like old CMD line file, you can always have that. That's why you use this command to create a backup of your CMD line. I already have did that. Now the next thing we have to do is we have to like edit our CMD line file. Now for that you just use this command, so sudo nano boot cmd line txt. So then you will get a file like this. Now here something will be written. You can delete that because you already have a backup, so if anything goes wrong you will have it. And you simply copy this line. So it's a pretty big line, so you just copy that whole line from my repository and you just paste it here. I already have pasted it, and then again Ctrl X and Y. Now here we have done all the modification we need to do. Then you do a sudo reboot, so it will basically reboot. Now after that we need to check which port we are going to use for serial communication, and for that we are going to use lsl-dev. So we can simply write like lsl/dev, and that is going to show you like all these things. From there you need to search one thing, which is serial 0. You have to find serial 0 here. Now as you can see, serial 0 is pointing to TTY-AMA0. Now we have to remember this thing. For the remaining of this whole video we are going to use this TTY-AMA0. In your case, if it's different, if it's like TTY-SEM or TTY-S0, you need to use that one. Remember what serial 0 is pointing, you have to use that one. Okay, so for all the commands where I will use TTY-AMA0, even in all the codes I will use TTY-AMA0. If in your case it's different, you have to use that one. So please check that one. Now after you will check it, you need to do two things. You have to disable getty. Now basically to disable getty, what you need to do, these two commands are needed. So the first command will basically stop getty for temporary, and the second command will basically disable getty like permanently. Okay, now we need to do that because basically getty uses the serial communication. So to use the serial communication we need to disable this. Okay, so you can just execute these two commands. I already have executed them. Okay, so my getty is basically disabled. Now after you will execute these two commands, the last thing you need to do is like so here we have completed all the necessary things we need to do before we can do the serial communication. Now we are able to do the serial communication. So before we write any code, I just need to check. So if you just need to check like if it is working fine or not, like if your serial communication is working or not, you can simply do this thing. Like you can install Minicom. Using Minicom you can actually check it. Now it's not mandatory. If you just want to check, you just install this. So sudo apt-get install Minicom, and then you just need to do like Minicom. You need to mention the baud rate, so it's 9600, and you need to mention the port. In my case is TTY-AMA0. Also one thing in the last command, if you see here, is when we are actually disabling or stopping the service, getty service, we are mentioning the port number. In my case, it's TTY AMA0, but in your case, if it's different, you need to modify this. So it may be TTY ACM0 or maybe TTY S0, depending on your port number. Like your port, you have to change this. Now in Minicom also you need to mention the port. So here also I am going to use TTY AMA0, but in your case it may be different. Okay. So I'll just use that. Now we will get this serial console. From here we can actually communicate through the Arduino. So we can send basically data to Arduino, and also you can receive it. So to do so, what we need to do is we have to upload a sketch in Arduino. Now if you just go to my GitHub repository, you will get a code called Arduino receive, which basically, as the name suggests, receive the data from Raspberry Pi. So you just open that file, and if you see, it's very simple. What we are doing is we are just beginning a serial communication. Then we are seeing that if there is some data available, we are going to read that out, and finally we are printing that. Now here we are going to receive ASCII values. That's why I'm just converting them into characters. Okay. Now before we upload, we need to see that we have to check the board. So here I'm using Arduino Nano. So I'll choose Arduino Nano. The processor I will choose like Atmega 328P old bootloader, because this is my port processor in my so my Nano has this processor. And finally we will choose the port number. Now here it's very important, before you will upload the sketch, make sure you have disconnected the TX-RX pin, okay, from your Arduino. So in our Arduino we have connected pins to TX-RX. You must have to remove that, except that your code is not going to be uploaded. So you remove those two pins, you upload the sketch, you again connect them. Okay, this is the process, and every time you will upload any sketch in your Arduino, you have to do this. Okay, except it's not gonna work. So as you can see here, we are uploading it, and it has been uploaded, so it's done. And now we can simply connect our TX-RX back with our Arduino. Okay, and also you need to connect that back, except that obviously there will be no communication. Now here I have opened the serial communication. Now in our Raspberry Pi console, serial console, you press any character and you will see the character will come to Arduino. A, B, C, D, E, F, whatever you send, like Y, U, I, whatever you will send, you are going to get that in your Arduino, the serial monitor. So that means our serial communication is working just fine. Okay. So from here you know that it's working fine. Now we can just go to the codes and we can write some Python code in Raspberry Pi side and some code in Arduino side, and like we can do different kind of communications. Okay. Now one thing is I don't know really how to actually you can turn off the this Minicom. So how you can exit from that. Definitely there should be some shortcut, but I really don't know. So what I do is like I'll just simply log into my Pi using another SSH connection, and I will simply kill the Minicom. Okay, so this is what I do to like exit from here, but there should be definitely some better way. Okay, you can find it out. Okay, so now so we have tested it. Now it's time to write some code so that we can check. So we already have the code for Arduino to receive the receive some data. Now it's time to write some code to like send some data, okay, from Raspberry Pi, and we are going to use a Python code. So if you see my GitHub repository, there is already a code written. So Raspberry Pi send, obviously whenever you are using Arduino receive, you have to use Raspberry Pi send. So you just copy this you just copy this code and let's just paste it here. So let's just go to desktop and let's just create a new folder called serial, and let's just get into serial, and now I'll create a file nanosend.py, and now here I just pasted this code. Now let's talk about this code is same. We are just importing serial time, then we are creating a serial, like here we are creating a like what you can say, like serial object, which is basically where we are giving the port number, the port we are using. So obviously in my case it's AMA0, in your case it may be different. We are mentioning the baud rate, we are mentioning a timeout, and then we are here creating an infinite loop where we will just take a single character and we are going to write that to the serial connection, so that basically Arduino will receive it. And if we press Ctrl C or Ctrl Z, it's going to be keyboard interrupt, and our Arduino serial like this serial connection will get closed. Okay, this is what this whole code will basically do. Okay, pretty much simple. So now we'll just save it with Ctrl X Y, and now we can simply run it. So Python send.py. Now here I am using Python 2, but it should also work with Python 3. Okay, let's just use Python 3. I think most of the people will use Python 3, so let's just use Python 3. So enter the character. Let me just open the serial monitor here. So here we have already uploaded the Arduino receipt, so I'm not going to upload it again. So let's just press the character. So A, press enter. You see we have received A here. So B, we have received B. E, we have received E. Now if we just write ARI, we are going to receive ARI, but we will receive it like not ARI as ARI. We will receive A, then R, then I. Because here in like in Arduino side, we are just basically reading a character. Okay, we are reading, so we are reading byte by byte. That's why you're not going to get ARI. Now if you are wondering how we can receive ARI, don't worry, I will show you that also. Okay, so this is the first code where we are sending data from Raspberry Pi, we are receiving the Arduino. Okay, so the next thing what we really need to do is obviously receiving a Raspberry Pi, sending from Arduino. Now for that, again you just go to my repository and there you will get that Arduino send. So you just open that file, you copy this. That's again very simple code here, nothing special. So again what we are doing here is, okay, we don't need this thing here. Actually I was doing some experiments here, but we don't need this thing. Okay, yeah, so what we are doing is, again we are we are creating a serial, beginning a serial communication connection, and then what we are doing here is serial.println a. So serial.println, so here we don't have anything called serial write. Whenever we are doing print on a serial connection, it is basically going to send that thing through the serial connection. So it's like similar to serial.write in case of Python. Okay, so see, whenever we will do like serial println a, that means it is going to write a through the connection, and our Arduino, our Raspberry Pi will receive the a. And do you know we are doing a plus plus? That's because like I just have written a code which will basically send a, b, c, d, e, f, g, something like this. So a, then we are doing a plus plus, which is going to increment the ASCII value. So it will make it b, d, c, d, e, because initially a is defined as character a, so it will increment like b, c, d, e, f, g, h, something like this. And also we are giving a delay of like 1000. Okay, so this is going to value, and this is not a practical program, this is just an experiment you can say. Now you can just use these techniques to create anything you want to use, like any practical thing you can build with it. Okay, now again we will just remove the connection of our Arduino, like the TXRX, and then again we will upload this code there, and I think it's almost done, and it's done. Yeah, now again let's just connect it, the TXRX. Okay, now here we have something called Raspberry Pi receive. So you just open Raspberry Pi receive, again a pretty small code. Now in this code I haven't implemented that like try catch. Okay, so you can implement of yourself. Okay, so nano, oh not, we're not working on this one. Yeah, here, so nano receive dot pi, and now let's copy paste it. So it's pretty it's same, like again you are creating a serial like object, and then again the same port, same baud rate, same timeout. In this case we are using a like method called inwaiting. So if we have something available in our serial connection, we are going to read that out, we are going to print that. And like I said, here I have implemented a try catch, but you can implement from the previous code. Okay, and okay, let's just run this thing, python receive.py. Okay, and here we are getting some garbage value, and this is because now if you see I have rebooted restart the Raspberry Pi, reset the Raspberry Pi. Now we are getting a, b, c, d, e, f, g, h, and in this way we are going to get up to z, and then we are going to get some random values like this, because like in ASCII it is incrementing. Okay, so like after z there are some ASCII values for which we doesn't have characters, so for that we are going to get garbage values. For example, just let's see here y, z, and okay, here we are getting symbols, but after a certain time we are going to get, yeah, now as you can see we are getting this random values. So that's it, it's working pretty fine, and you can write the code in this way. Okay, now we are just, so as you can see here we are getting, whenever we are just pressing Control A, C, we are getting some errors. This is because I haven't implemented that try catch. Okay, so now we have seen two things. One is sending from Raspberry Pi, receiving in Arduino, sending for Arduino, receiving to Raspberry Pi. Now the last thing which is remaining is bidirectional. That means we will send from Arduino, receive at Raspberry Pi, at the same time sending from Raspberry Pi, receiving at Arduino. Okay, now for that there is a code called Arduino Bidirectional. So you just open that, and again a pretty simple code here. So actually we can open it from here also, I think. Okay, let's just paste it here. So what we are doing here is again same. If there is some data available, you just read that. And here I am using string. Like I said you that we are going to see how you can receive a string too. Here we can receive a string. Here rather than byte, we are using some string. So if you send ARI, we are going to get ARI, not ARI. We are not going to get that. So here we are going to get string. So you read the data, then we are going to print that. Okay, and also we are going to print basically I am Arduino. Okay, so what will happen here is we will get a data, okay, from Raspberry Pi, and then we will print I am Arduino. So Arduino is printing I am Arduino, and also it is going to, so Arduino is sending I am Arduino, also it will send the data which it will get from the Raspberry Pi. Okay, it's important. Arduino is also getting the data. Arduino is also sending I am Arduino, and also the data it is receiving from Raspberry Pi, because as you can see data equal to read string, so it is reading the data Raspberry Pi is sending, then it is again repeating that. I mean, you can see it's kind of echo. So basically you are receiving something, you are just getting something, and you are just sending that back. Okay, this is about Arduino. Now if you see the Raspberry Pi bidirectional, you will see this is how it looks like. So let's just copy it, and let's just go to our terminal and write nano bidirectional bidirectional.py. Now it's again same. So again creating a like, okay, so here the timeout is like, it should be 0.1. Okay, and here again we are doing like creating the serial object like serial connection, and then again we are using an infinite loop. Now here what we are doing is, here we are basically writing to the Arduino, like writing to the connection that I am Raspberry Pi, and then it is receiving what like our Arduino will send, and then it is going to print the line which Arduino will send. Okay, now try to understand what's happening in both of the cases, in Arduino like and in Raspberry Pi. Raspberry Pi is sending just I am Raspberry Pi, and it is going to print only what Arduino will send. Okay, now Arduino will receive what Raspberry Pi will send, and at first it is going to send I am Arduino, and then it will send the thing that our Raspberry Pi has sent. So in our Arduino side, we will get I am Arduino, then I am Raspberry Pi. Why? Because Raspberry Pi is saying I am Raspberry Pi. So it will print both. And in our Raspberry Pi side also, at first Raspberry Pi will get I am Arduino, because this is what Arduino is sending. Then our Raspberry Pi will also get I am Raspberry Pi. This is because it is sending Raspberry Pi to Arduino, and Arduino is echoing that back to him. Okay, back to it. Okay, so both of them will get like I am Arduino, I am Raspberry Pi. So that's why it's a bidirectional, because our Raspberry Pi is sending I am Raspberry Pi, and our Arduino is sending I am Arduino, but both of them is going to print I am Arduino, I am Raspberry Pi together. Okay, so that means we are like able to do bidirectional communication. So now let me just run this code, or before that let me add a timeout. Let's just make it 0.1 rather than 1. It is 0.1. Yeah, fine. Let us just save it. Yes, and now let's just use Python 3 and bidirectional. Yes. Okay. Okay, it is not working. This is because our Arduino is not sending anything. So before that, we have to upload this sketch. So let me just upload it. Okay, now it is done. Now let's just open this, and now let's connect back our TX and RX, and now let's run this code. And as you can see, I am Arduino, I am Raspberry Pi. Same here, I am Arduino, I am Raspberry Pi. Okay, so what's happening? It is receiving I am Raspberry Pi, then it is sending I am Arduino, and I am Raspberry Pi. So both are basically getting both of the lines. Okay, so this is how it is working, and as you can see, the bidirectional connection is just working fine. So in this way, we have seen like all the three things. The first, Arduino will send, Raspberry Pi receive, Raspberry Pi send, Arduino receive, and the bidirectional. So using these three concepts, I think you can actually make anything you want. Okay, like any serial communication you want. Okay, and that's it. And this will also work in case of the USB connection. If you do, instead of GPIO, if you do it USB, like this, all the code will be just the same. Okay, just remember one thing, you need to change just one thing. which is like you may have to change the baud rate, okay, depending on your usage, and you also may have to change the port, which is AMA0. In my case, in your case, it can be different. This is the only difference you need to do, except that everything will be just the same. And also the instruction file is in the description, so basically in my repository, so you can also get all the instruction there. You just follow them up, and you can like run all these codes, and then if you get any kind of issues, you can also always let me know in the comment sections. Okay, this is all about this video, guys, and I hope you have liked this video. In that case, hit the like button and please subscribe to the channel, so that whenever I will upload a new video, you will get a notification. And also I'm working on many new projects, so all those videos I will upload very soon, so stay tuned, and we'll see you in the next video.